Cosmic Ray, the quantum mechanic. How you all doing? We're here today, we're going to learn some atmospheric chemistry. How are we going to do that? We're going to do some balloon molecules. Green is going to be oxygen. We're going to show how the Earth works. The Earth. Seasons. You know how the seasons are formed? It's from the tilt to the Earth. It has nothing to do with how far away the planet is from the sun. So where do we begin? Our atmosphere has a thin layer around the Earth. Thin, thin, thin. So you picture the Earth. You've got a thin layer of air. Now what we need to understand is the air gets denser towards the bottom. Closer to the surface we get, right? Well, what happens is we are constantly getting bombarded by cosmic rays. Cosmic rays are rays of particles and waves that come from deep space. So the only way a cosmic ray is going to get us is when we are facing away from the sun. But what we have is something called the ionosphere. What this is now, we have two shells around the Earth, okay? The first shell is just like an atom. This is where your positive protons are. And then the outer shell is a negative. So when particles come from the sun to hit the Earth, they get deflected. The Earth is a magnet, North Pole, South Pole. So the protons have a plus charge, which means when they come running in, streaming from the sun, blam, they hit and they're going to get put into the Earth. This, I think, is what the theory of how we get molten liquid nickel in the core of the Earth, I think, is from all the energy coming from the sun, striking the ionosphere, and then the particles have to go somewhere. Some of them, they'll show this sheath going off into space, you know, magnetosphere they call it. Well, these Van Allen radiation belts, they call them. So the positive and negatives actually direct the particles. Now, I don't know which, and I've talked to atmospheric chemists from NASA and everything, which go in the top and which go in the bottom, because there's a positive, negative, north-south pole. Nobody's answered that. So electrons come from the sun. Protons, which are hydrogens without their electrons, come also. So the positive is going to go in one side, negative is going to go in the other. Now when they talk about life out there on other planets, this is what you need. You need this kind of thing to protect you from these charged particles, because high energy protons coming from the sun, that's called radiation. You also have alpha particles coming too. So you get these big massive particles hitting you on the surface of your planet. If you don't have a magnetic field around you to protect you and steer those particles somewhere, you're toast. So that right there cuts down the probability of finding life on other planets, because a lot of them don't have these magnetic fields. Now when you look at the Earth, I was so proud of that one teacher. He's up there lecturing, he's turning the Earth, and he said this little girl raised her hand, and he thought, oh, here's this little know-it-all girl, and so he kind of ignored her, and then at the end he goes, yeah, what do you want? She goes, you're turning it the wrong way. See what I'm doing here? Turning it the wrong way, right? The only way I know it is when you see New York City, here's New York, right there on the coast. It's hard holding this camera here. Well, the sun rises in New York before it does in California. So picture the Earth turning in front of the sun so that New York, California, Hawaii, China, England, New York. Now, magnetic field of the Earth. Where's the magnetic field? Oh, the North Pole. Well, see the way the Earth turns here, right? We got it going right here. This is the way it's going to turn. It's got a 23.5 degree tilt. And for those of you that don't know, this is where the seasons come from. The tilt to the Earth. If you picture the front of you there being the sun, when the Earth is tilted, I'm going to over-exaggerate it a bit here just to show my point. When it's tilted, the direct sunlight is going to hit on the southern hemisphere. And then when it's tilted, when it goes around the sun on the other side, if we could turn the camera around, what you're going to see is it's still pointing this way. The planets do an ellipse, which means it's not a perfect circle around the sun, which means if you think about it, the Earth speeds up and slows down. This is something else they don't tell you about. So, Earth tilted speeds up going around. When it's furthest away is actually when it is summertime. This is why you got to know it's the tilt, because now the tilt, if I could show it around backwards, is going to hit the top of the Earth more directly. When it's further away, see, what I'd have to do is turn this around backwards and you'd see that it would hit it more directly, okay, because it'll be backwards. So the point is, it's the distance from the sun has nothing to do with the seasons. It's from the tilt of the Earth. Now this is why I say the Earth is so unique, because look at the southern hemisphere. When the Earth is closest to the sun, this is where all the water is. Have you ever noticed that? Most of the land mass is on the northern hemisphere up there. See that? So when the southern hemisphere gets exposed to the sun, like Australia here, they're closer to the sun. So summer in Australia will get you a deeper sunburn than summer in Florida. Even though Florida's closer to the equator, we're further away. I hate these questions. How far away is the Earth from the sun? And what do they say? 93 million miles? Well, wait a minute. It does an ellipse. So there's a time it's closer, there's a time it's equidistance, further, same distance, equidistance, and then closer. So doing an ellipse creates the phenomenon of having your daylight, right? It's not that the Earth is turning, it's that when it's over here, the sun is directly on the equator. When it's over here on this side, directly on the equator. Then when it's over here, though, see the way the days now? The days are going to be shorter daylight time in the northern hemisphere in the winter. So this is something you got to know your science. The Earth is closest to the sun in winter. Okay, another good trivia question to ask, what's the hottest planet? People would think Mercury because it's closest to the sun. It's the atmosphere around Venus. It traps and holds the energy, so that Venus is the hottest planet in the solar system. So for our conversation here, all the water in the southern hemisphere absorbs the heat when we're closest, which keeps the steady temperature, because there's something called heat capacity. The land, if you notice, when the sun hits the land, it heats it up, right? Well, then when it turns around at night, it gets cooler. Well, water, when you heat the water, turn it around, it holds the temperature better. It stays warm. So all the energy that the oceans are absorbing keeps the planet at a steady temperature. Another good thing about this is heating the water 1 degree takes a lot more energy than it does to heat the air 1 degree. So when you hear these people talking about the global warming, oh, what is a 1 degree increase in the atmosphere, in the water? Well, it's a heck of a lot more than 1 degree increase in the atmosphere. Because what does water do when you heat it? It expands. So you heat all that water in the Pacific Ocean 1 degree, it's going to raise the sea level. It's going to add more energy to the point where when you get a hurricane coming into the Gulf of Mexico now, it's going to have more energy in that water. Water holds energy a lot more than the air does. So you got to know your chemistry here. Look at this Gulf of Mexico here, people. Okay, this is criminal. You teenagers, you ought to be marching on Washington. What this is doing to the environment is just criminal. And it's not that they were drilling. It's not that there was an accident. It's what they did afterwards, okay? We won't get into the politics of that. So what we need to understand now is energy. How do we detect energy? How do we learn about energy,